My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 452. In this lecture, we will try to understand feature slicing. Another interesting idea is feature slicing. So, let me try to explain with an example. Let's assume I have height h, weight w, hair length HL, eye color EC, country or origin. Now, let's say I want to predict the gender. Gender prediction is my YI and hair length, hair weight, hair length, eye color, country is XI. Isn't it? I have these 5 features. Which 5 features? Height, weight, hair length, eye color, country. Isn't it? These 5 features. So let's assume I have only 2 countries. My country variable is basically categorical variable with 2 countries. First country, let's say USA. My second country, let's say India. So in your total data, let's assume 80% of your data, 80% of your rows belongs to with column country as India, isn't it? And of course 80% of your data, that means 80% of your rows belongs to with column country as India. Let all these guys 80% and 20% of the cases you have this country of 20% of the cases you have this country as USA. Now what happens is this: when you try to build a model, capital M, let's assume we try to build a model M using all of the data, isn't it? Using all of the data, all the total data is capital D. Suppose you are building a model by using all of your data, because you have this difference. Which difference you have? You have 80% of data belongs to one country, that is India. 20% of data belongs to other country, that is USA. Let's assume we are trying to minimize average loss or average, let me say, log loss, isn't it? Suppose your loss function is average log loss. Whether you do mistake for somebody belonging to India or somebody belonging to USA, the mistake is equally weighted, because it is as simple as average log loss. So what happens here, when you have this imbalance, when you have these types of imbalances, isn't it? 80% of data, 20% of data means it's imbalance, where your one category which dominates other category, which is less dominating, isn't it? There are 2 categories, one is dominating and another one is less dominating. In such a case, what happens is the model capital M, which you build on total data capital D, will start performing much better. Look at this. Indians have very different different hair, different weight, different hair length, isn't it? Eye color, isn't it? Observe from people from USA. People from USA are typically taller, isn't it? Typically taller, heavier than people from India, because various genetic reasons and various social reasons. So you see that there is a distinctive difference between people from India and people from USA. In such a case, since your model is predominantly from India, it tries to perform better on people from India because they are majority, isn't it? It performs better on India because of majority of data points belong to India. It tries to perform, not always, sometimes worse for the data points from the USA. This can be observed in the real world. In such case, let's assume I have lot of data. Let's assume I have 80,000 points for India and 20,000 points for USA. I have sufficient data. It's not about sparsity of data, but since majority of them from India, it tends to perform better on Indians than USA because the majority is 80% of data. There is a systematic difference between people from India and USA. In such a case, what do you do and how do you detect? First of all, you can detect it very easily. First, you train model capital M on your total data. Now, you take test data. Now, take your test data. Split your test data into people from India. These are the people from USA, and look at the error on all the people from India, and look at the error on all the people from USA. Let's plot these distributions. If your distributions of errors on India is like this, and distribution of errors on USA is like this. This is on x-axis we have error, on x-axis, on y-axis we have PDF of errors. That is important. On y-axis you have PDF of errors. You quickly notice that your model is doing more errors on people from USA, isn't it? More error on people from USA than people from India. You can easily detect something like this. There is a discrepancy in the data. 80% of data from India and 20% of data from USA, even in test data, isn't it? So on test data, when you try to predict your labels, you can also compute errors. If errors are distributed such a way that you observe more errors for people from USA and less errors for people from India. One strategy that works is you split your total data, isn't it? Yes, one strategy that works is you split your total data D into two parts. What are the two parts? And your data can be splitted like this. How can I split your D? I can say D. This is, I can say D India. I can split like this: D India, D USA. How many points are there here? 80,000 points. How many points here? 20,000 points. Here I will get model M1. Here I will get model M2. And your train, one strategy that works is you split your total data capital D into two parts, and you train model capital M1 on all the people of India and train different model capital M2 from USA. And you can do this because you have sufficient amount of data, because you have 80,000 points in D India, 20,000 points in DUSA. You have sufficient data here. If this is small, let's say DUSA, if it is small here, you can't do much. Since you have sufficient data of 20,000 points, it is better to slice. It is better to slice your data using your feature, especially features like this where there is a distinctive behavior between these two categories, USA and India. USA is one category, India is another category. It's sometimes beneficial to actually training one model M1 for people from India, one model from people from USA, and apply this model. Now you might ask, what do I do at runtime? At runtime, you are already given the country as a feature. If the country of the country or the origin, India, if the country or origin is India, then apply this model M1. If the country or the origin is USA, then apply this model M2. Very simple idea of slicing the data based on features, isn't it? Idea of slicing the data based on features, especially when you observe things like this. The two conditions it needs to satisfy. What are those two conditions? First condition is each category 1 and category 2 should be very different in their behavior, and second one is you need to have sufficient number of points for each slice of data, otherwise it won't work. Then you basically train two models. This happens with any major internet company, isn't it? They have desktop traffic, which is very different from mobile traffic. Earlier, what they used to do is, suppose I want to predict somebody will make a purchase at Amazon or not. Let's assume that is the problem. I'm trying to solve. People could combine both of them into one data set. Let's assume I don't know those numbers exactly. Let's assume 70% purchases comes from desktop, and let's assume 30% purchases comes from mobile. The way things work on mobile phone is very different from the way things work on desktop, because mobile phone has much smaller interface, desktop has much more easier interface to use. Whatever, there could be 100 reasons how desktops are different from mobile. So if you train one big model, capital M, combining these two data, its performance would typically be worse off than just taking mobile data, desktop data, building model M1, taking other data which only mobile data, building model M2. Because you have sufficient amount of data, there is no scarcity of data, and you know that mobile users tends to create significantly differently in some cases than desktop users. Probably mobile users are only checking the price is low, the only cheapest items. For expensive items, they tends to go to desktop, isn't it? More careful looking at deals and all sorts of them. This is personally I have encountered in my professional career, where instead of taking the whole data in one big chunk, it is better to break it up. When you have sufficient data, there is difference in behavior of these two features. Just go through this lecture and try to understand how we are discussing this feature slicing. If you have any difficulty, please keep a comment. Thank you very much.